Here we'll discuss classification tree, one of the three data mining methods we talked about. So classification tree is part of a much larger problem called classification. But the classification and regression trees, it's often called CART, classification and regression trees. It's a very popular and simplistic method that is used in practice. They're very popular simply because they are very easily understandable and it's in the form of a tree, and this can be converted into a long rule. For example, so you want to see in the bank, you want to give loan, but you want to make sure the person who gets the loan returns with interest. So we might have a tree that looks at income. Okay, so if the income is less than 50k and greater than or equal to 50k, we see they have different behaviors. Even in that, if you look at the family size, okay, so you could have less than 2 members, or I'm sorry, less than 3 members, or greater than or equal to 3 members. Then you can look at existing loans and so on. Okay, if the income is less than 50k, family size less than 3, I would say yes, that they return. Or you could have other variables here and you can look and say yes and no, which means that if income is less than 50,000, if the family size is greater than or equal to 3 members, and some other variable here, it could be your education. Okay, if it is greater than or equal to your undergraduate degree, then no or less. So you can have a decision tree like this. So what does it tell? So this is at every level you're splitting and you make decisions just like your decision tree that you learned, and you have a tree here. At the end, these are called the leaf. These are decision nodes where if they satisfy this condition, they're likely to give back the loan, otherwise no. So the question is, how do you come up with this classification trees? So underlying this classification tree is basically regression, and there is a way to generate this classification tree from any data. So if you have a large data first, so you have large data, and what I do is I split that data. I split that data into two training set. Means I randomly take some data and I train these decision trees to generate the decision tree. I can take this result that I get and apply it on another data set to validate. So here I have two major sets, training set and validation set. You can also do something else. Once you validate it, you prune your tree or refine your tree and you can apply it on test data. So there are three things you can do. You need to have training set and validation set, and you can build on that to say we'll have test data. So if you have say 1,000 data points, I might take 600 for building that tree, or I might take 300 for validation, and after refining I'll apply it on 100, and I want to see how well this tree functions. Often you see many of them don't separate the validation and test data. They'll just have one data set that does both validation and test. So the question is, how do you know whether you're doing a good job? Okay, so in reality that you have the data, you have an answer yes and no. Okay, now in the training set or the training set, you develop some tree and you're applying that applying that tree that you've generated to validate or to test, and you see how well does it do. So does also yield yes and no. So this is based on your model. This is based on actual. Ideally, you should say that in ideal situation, your prediction, the model that you're generating, the tree, should basically say from the model when you apply it to the validation of the test data, and everything else also comes here and nothing here, which means that you have no error. Likewise, in the actual it is no, you should theoretically get nothing from the model and everything is here. When that happens, you know you have a zero error rate. Okay. But in practice, you'll start to see you will have some sort of an error. As long the error is less, then you're okay. It means you have a very good classification tree. This is very heavily used in the practice for decision making. That's why they ask you for information about your profile or your characteristics, and they will decide whether to send you a coupon or not, whether to give you a loan or not, and so on. So let's review that. So you get data. You classify the data into two major sets, the training set and validation set. Often they'll say, okay, I'll validate it, I'll refine the tree, and then I'll apply it on test. So any given data, either you classify into three different, randomly generate three data sets, or you can do two. Once you generate the classification tree from this data set, you apply it on your validation set, and you develop this, what you call the confusion matrix. Often some of them calling you error matrix or confusion matrix. Ideally, you want to have that confusion to be as low as possible. So that's the basic underlying principles in which you use classification tree.